Today we're going to start off with a parabola, and I've got a basic parabola drawn down here with a straight line, and it's marked as f of x, which is the parabola on this side, and I've got g of x, straight line on that side, so it's all been drawn, and it's a basic function. And I've got a couple of questions. The first one is find the coordinates of p, and p is the turning point of that function. Okay, but I want you to do it in two different ways. So, in the exam they want specify which method to use, but I want you to get used to both methods. Okay, so we want to find the coordinates of p, but we're going to want to use two methods. And firstly, for a start, I'm just going to distribute this x into this brackets, so I know what my fx is. And I think the common way is to use this minus b over 2a, and then we'll punch in more. This is my b, which is a positive 3, and 2, and yeah, so that's my turning point. And to find my y, I'll just sub it back into the function. Squared plus 3, negative 3 over 2, and I put all those in my calculator. I've got negative 9 over 4, so my coordinates of p would be negative 3 over 2 and negative 9 over 4. Okay, let me just clear that up a bit. 9 over 4. Okay, so that's the first method. The second method I'm going to use completing the square. I don't know if you can remember that. So let me write down the function. So f of x is x squared plus 3x. Now usually there is some sort of digit on this side. In this case there's nothing. Okay. And how do I complete the square? Is by taking half of this and squaring it, and then I also have to subtract that half of it, squaring it. And now these three first terms will create my first bracket, an x and an x, and one of those 3 over 2's goes in here, and this just goes to 9 over 4. And from here onwards I can see this is my p, my q, my x and my x, my y. And this, you always have to change the sign to a negative. It's a plus on this side, but this one just stays exactly as it is. We don't change those signs. So now what we're going to do is we're going to find, this is question 1.2, it says find the average gradient of f between points x minus 3 and x minus 5. So what it means is somewhere on my function, I've got an x coordinate of minus 5, and I've got a x coordinate of minus 3, and I need to find the average gradient between those points. But now, can you remember that I can only work out a gradient if I've got two y's and two x's, delta y over delta x. So the difference between my two y's and difference over the difference between my two x's. But I've only got one. So what we need to do is we need to find those x values, or those y values. So what I'm going to do is going to take my original function, which is f of x, equals x plus 3, and for a start I'm going to sub that x with, I think the first was it a negative 3. We're going to put a negative 3 in there, so this is negative 3 plus 3, so this is 0. So I've got a coordinate where my x was minus 3. I got a y of 0. Okay, and then we're going to do it again, and this time I'm just going to sub a negative 5 in. So there's negative 5 plus 3, so this is negative 5, and this is negative 2, so that gives me a positive 10. So I've got a coordinate of where my x was negative 5, my y was 10. Now I can work out my average gradient. So let's just go average gradient. Let's just write it out. So between those points I can get my average gradient equals y2 minus y1 over x2 minus x1, and that will give us, let me just get a new page. I'm just going to take my y, where's my y minus my y, so it's 10 minus 0, and minus 5 minus 3, which is a plus 3, so this is 10 over negative 2, which gives me an average gradient of negative 5. Okay, so the next question, for which values of x is f of x greater than g of x? Okay, so what does it mean? What does it mean when one function is greater than the other function? It means the one is above the other. Okay, so let's mark where the one is above the other. Where's f of x above g of x? So does it make sense? It's that spot there and this spot there. So it's those two. There's those x values. All those x values are very relevant, where f of x is greater above the straight line. Okay, so but they're asking for x values. So I need to find that x value, and I need to find that x value. And if I find those x values, it's easy to answer the question. But how do I find x values? And these are intercepts. These are spots where these two graphs are intercept. They are actually, so both those lines are that's intercepts of both these functions. And how do I find intercepts? Okay, PLE f of x equal to g of x. So when two functions are equal, that's the intercepts. Now what is f of x? F of x is was it? Yeah, it was x plus 3. That was f of x, and g of x was a negative half x plus 2. Okay, so just let's simplify this. Get rid of the brackets. I can see a square to the power of 2, so I know the one side must be 0 plus 3x. I'm just going to bring my half across, becomes positive half of x equal negative 2. Let me just remove that. Negative 2 comes across, equal to 0. I'm just going to add these two up, and I'm going to get 7 over 2x minus 2. Now usually I factor, but it's difficult to factor with a fraction, so I'll get an LCM. My LCM is 2. So my first term didn't have the LCM, so I have to multiply it with the 2. Second one had the 2, so I'll leave it out. Third one, I need the LCM. Brilliant. Now I can factor. So this is 2x, and I think this would be 4, 1. We need a positive 7, so it's a plus and a minus. Let me just do the in and out the test. That gives me 8x minus x. Yep, brilliant. So it works out. And so I know that 2x minus 1 equals 0, and x plus 4 equals 0. Remember to write or. So x is a half, and x is negative 4. Now I just need to go and put it into my graph. Now obviously the half would be, the negative 4 would be on this side, and the half would be on this side purely because of the 0 on that side. So I don't need my y-intercepts at the moment. They don't ask for it, because I need to find for which values of x is f of x greater. So let's just color that in. So it's this piece here and this piece here. So how do I write it? So that will it make sense if anything smaller than negative 4 and anything greater than a half. Let's just write it. So x is smaller than negative 4, or x is greater than a half. I just want to make sure it's fine. Smaller than negative 4, yeah. Okay, so the next question says, find the coordinates of the turning point of fx minus 2. So it depends on what the question, what's the marks on those questions. So if it's 3 or 4 marks, I probably have to find it. Now I have to do some sort of equation to get there. And sometimes they say write it down. So I want to do both. I want to, let's say for instance, we have to do an equation to prove whatever the new turning point is. So what we'll do is we'll take the f of x. So there's a couple of ways of doing this. And the original function was I think it was 3. This was the original one function. So what we can do is we can just simplify this, and when f of x minus 2, if we want to find f of x minus 2, we'll just replace every x with a minus 2, x minus 2 squared plus, so you're going to replace the x with the x minus 2. So I just want to stand still at this point. So whatever f of x is, you're just going to replace it with an x minus 2, if it makes sense. So every x I've just replaced with an x minus 2. Okay, and now we can simplify. So this is a long way around, but let's just do it. So it gives us confidence whenever we do the shortcut. So we have to write these two brackets twice, but I'm not going to do that. I'm just going to simplify, and we can just take shortcuts. So it's x squared minus 4x plus 4 plus 3x minus 6. Okay, we're just going to simplify again. That will give us minus x negative 2, and now we can find out the negative turning point, 2a, and it's negative 1, so that becomes a positive 1. And then 2a, so it would be a half. So my new turning point is, so I just want to write down the old turning point, which was p, was negative 3 over 2, and negative 9 over 4. So that's the old one. The new one, so let's just call the new turning point pq, let's just call it q, would be a half. And as soon as, remember that this was x plus, was it x, oh no, x minus 2. Now this means it only my x get affected, my y doesn't get affected. So that's going to be my new turning point. No? So if I have to work it out, this is the way to show it. Alternatively, if I just have to write it down, I can just add 2. Remember that this says f of x minus 2. Now it says minus, but you have to remember at the x you always have to change the sign. So you're just going to add 2, and then it becomes a half. So there is a shortcut. So if you're not familiar with a shortcut, rather take your time and just go and work it out. But remember, time is not on our side. So basically, if I was in your shoes and they say and they tell me, what is f on x plus 3? I'll say, okay, I have to change the sign, so I have to subtract it. So I'll subtract it from there. If what was f of x minus 2, I'm going to change the sign, so it's plus, so I'm just going to add it to that, and we'll get to a half. Okay, so the next question is tough. It says L is a point on G. Okay, so let's just have a look at this. So L is a point on G, which is perfect. It's there, so it's perfect. And they say M is a point on my F. Okay. They say LM is perpendicular on my x-axis, which has been marked over there, so it's perfect. They say show that the length of LM can be written as this. So show that the length of LM can be written as this. Okay, so where do I start with this? So it's always, whenever you see these funny questions where they've got some sort of line that goes vertically, you always take the top functions minus the bottom function, always. So Lm equals the top function, which is g of x. It's always the top function minus the bottom function. Okay, what is g of x? I think it's negative half x plus 2, and then we're going to subtract the other function, which is, remember it's actually x plus 3, but I'm just going to multiply them in because I don't want brackets, plus 3x. Okay, and now we're just going to get rid of those brackets. Remember that this function needs to be in a bracket because there's a negative in front of it. So this becomes negative x squared, negative 3x, and then we're just going to simplify further. I've got negative x squared minus 3x minus half an x would be minus 7 over 2x, and plus my 2. So that's the easy part, and that's now the difficult part starts. I need to write this in this form, and you can see that this is in the turning point form, and where f of x equals what's it, x minus p squared plus q. We have to write it in that form. And how do we get it into that form? We do completing the square. Okay, so how are we going to complete the square? Firstly, I can't complete the square if there's anything if there's a coefficient of x squared, and there is a coefficient. At the moment it's this, so I need to divide with that negative straight through. So I'm going to take a negative out, so I'm going to factor. So I take a negative out of there. This becomes a positive 2 over x, and this becomes a negative 2. Okay, I've factored, and now I have to complete the square. Now I don't know if you can remember. What we do is and this is my method, there's many methods, I take this negative 2 and I just move it slightly to the right, and then I actually have to add something and subtract the same value on both ends. Okay, and what's the value that I'm going to subtract? You take this value and you half it and you square it. So if I take 7 over 2 and I half it, I get 7 over 4, and then you square it. 7 over 4 and you square it. Now this can be written as a square, so let's just do that. Negative. Now when I write a square, there's going to be brackets in brackets, so I have to use my square brackets. So let's just write this as a square. I keep my x and I keep my plus 7 over 4, one of them, and I square it. And then I'm going to punch all this in my calculator and I'll get negative 81 over 16. Close my brackets. Okay, but now we're not finished, because we have to distribute that negative into both these terms. Okay, so negative x plus 7 over 4 squared plus 81 16, and I think we have just proven it. Okay, so the next question, so that we've just worked out this. They say, hence, what is the max length of LM, which it and give the corresponding x value. So hence, what is the maximum length of LM and its corresponding x value? Let me just remove that, and it's there is a it's over there, and its corresponding x value. Okay, what does it mean? It means, now look at this. Remember that now that I've taken L and I've subtracted M, I've taken F and I've subtracted G. I've taken G and I've subtracted, no, okay. I've taken, sorry about it, I've taken the G of X and I've subtracted the F of X. Okay, and that would have given me the LM. Okay, and this is what we got. And now what we've got is we've got another parabola. And let's just draw this. It is a frowny face because it's negative. It's got a turning point there of, can you remember, you have to change that sign, negative 7 over 4 and a positive 81 over 16. Now listen to the question. What is the max length? And when they talk about max, it's all about the turning point's y value. So the max length equals 81 over 16, and the corresponding x value, negative 7 over 4. So it's actually quite easy. So it's what have we done? What we've done is we've taken an L and we wanted to work out the length of LM, top function minus bottom. I got it in terms of another function, which in this case was a parabola, and this is the evidence of the parabola. And that parabola has got a turning point, and the turning point hence will give us either a maximum or a minimum value.
Yes.
Okay, so the next questions they ask, find the domain of G and the range of X. Now, think of this. I've got a parabola. I've got a straight line, which is G. And this G just carries on forever and ever and ever. So it just carries on forever and ever. So whatever X I punch into my equation, it will always be valid. So this one is X equal R. At a right straight line, it's always x equal r, and my range as well, y equal r. The range of f. Now f is the parabola, and my turning point, the y value determines my range. So anything above my y value would be my range. So if I look at the sketch, this is my y value. So it's from negative 9 over 4 upwards. So how do we write it? So we're going to say x, it's y, it's range. Y is greater and equal than the negative 9 over 4, because it's greater and equals. And why is it equal? Because it turns on that y value here, which is 9 over 4. So it's anything above the negative 9 over 4.